Hello, welcome to this course on signals and systems. So, in this introductory video, I will introduce you to the terms signals and systems. So, basically, this course of signals and system deals with various techniques for analysis of signals and systems. Okay, so let us first define what is a signal. So a signal is a function of one or more independent variables. Okay, and carrying some information. So this is the basic definition of signal. And for example, it could be some physical quantity, for example, temperature, pressure, velocity, okay, etc. Now, if this is a function of one variable, then this is known as a one-dimensional signal or 1D signal. And for example, a speech signal is a 1D signal. Okay. Now, if it is a function of two variables, for example x and y, then it is a 2D signal. And the example is an image. Okay, so image is an example of a two-dimensional signal. Now, in most of the time, we'll consider the function or our signal to be a function of time. Okay, but it could be a function of space also. For example, in this case, x and y are the coordinates of an image. Suppose this is an image, and this axis could be x, and this could be y axis, this x and y, and this values here, x and y values, define the pixel values in image. Okay, and in this case, the image will be, this signal, 1D signal, could be a speech signal. So if you record and plot and speech, or you can see this on CRO, so it will look something like this. Okay, so the information is in this change. If the signal does not change, if nothing changes here, then there is no information. Okay, so now next let us see what is a system. So a system is an entity which works on some input signal. So there is some input, and it takes some input and produces some output. Okay, so for example, if we give a signal x of t, then the system produces another signal y of t. Okay, and so we can say that the system is an operator or a mapping which takes values from one set and maps them to another set. So this is set x and this is y. So it takes values and it maps them to different values in y. Okay, so this is a mapping. Okay, now what is the requirement of the system? Okay, so in order to so in order to process the signal, so in order to process the signals, that is, now what is the meaning of processing the signal? Means to extract the information, from signals, we require systems. Okay, so to process the signals we require systems. Now we will see few examples of systems. So the first example is a radar tracking system. So what is this system? So a radar tracking system, it detects an target or any aircraft, and based on its velocity and the current position, it can predict the next position of the target. Okay, so what are the inputs? A typical input could be the present location of aircraft plus, say, its velocity, let us say, and so its present location and it based on its velocity, this radar tracking system could produce the future location of aircraft. Okay, so this is a system which takes the present location and velocity as an input and produces the future location of the target. Okay, so this is an example of a system. Now another example could be a weather monitoring system. So weather monitoring system, what does it do? It collects the data from different regions, and for example, any particular region, it collects the data such as temperature, pressure, wind speed, and so on. And based on that data, it can predict the so based on the collected data, for example, temperature, pressure, wind speed, etc. So based on this data, the system, what it will do, it will perform some of calculations and it can forecast the weather. Okay, so for example, they can say what are the chances of rain in a particular region, or even they can predict and the possibility of some natural calamities, for example, any cyclone or tsunami, and they can issue a warning, and so that the corrective measures can be taken in due time. Okay, so this is a weather monitoring system. Okay, now third example we'll take from the third example is from electrical engineering, and that is a filter. Okay, so what is a filter? So a filter is a system which filters out the unwanted frequencies or noise from the signal. For example, this signal xt, and suppose it is corrupted with noise. As you know, when a signal is transmitted over a channel, it may be corrupted with noise, and we want to remove this noise from this signal. Okay, so what we can do, we can pass it through a filter of certain frequency, cutoff frequency, so that it can remove this noise. Okay, so what we want it to produce an approximately, uh, this signal should be an approximate replica of this x of t. Okay, so this is an example of a system. So this filter is a system which performs some operation on this input signal, which is x of t, signal plus noise, and it removes the noise and produces a signal which is close to this original signal x of t. Okay, so what we have seen in this lecture is that what are signals, what are systems. Okay, and we have seen few example of the systems. So thank you and see you next time.